Hello everyone. My name is Dego and this is a video uh, that I am trying to make a new series for math, and this will teach you derivatives. Now, what is a derivative? A derivative, uh, first we're going to start with a function. So what is a function? Function, so let's start function. Oh, that's too much. There we go. F at x. And let's make a graph. So a graph might look like this. So at 1, at 2, at 3, at 4, at 5. And here it's going to have 1, 2, 3. So this graph, oh, let's say 4, because we're probably not going to get to 5 anyway. So f at x, let's say y equals x. This is a function. So this is a point, this is another point, this is another point, this is another point. When you sub in an x, you get the y value. The y value is in this axis, and the x value is this axis. Now, if you connect all these lines, because a function is not a sequence, and we'll get to sequences later, but a function is a lot of numbers put together, where when you put in, it's an equation where when you put in an x value, you get a y value. Now, these two axes could have any name. It could be z and x, y and z, anything. But we're going to work with x and y for now. Now, what is so special about a function? Well, a function can't do this. Why not? Well, because if you have a function y equals something, let's say x, that means that every value of x corresponds to a value of y. But here, when you have an x value, you're going to have two values that correspond in the y. So that means you can't have two two values of y for one x. Now, the opposite can be true. So, if we have the same graph, but it does this, that is possible because a y value can have two x values. Why? Well, because y equals, let's say, x squared, will have two values for x. So if I were to draw y equals x squared, then I'm going to just draw the right half of it. So this is the x. So 1, 2, 3. And this is 1, 2, 3, 4. Well, I'm obviously not going to get to this point, but starts here, actually starts here, then goes to 1, and then goes to 4. So it looks like that. On the other side, if I were to draw it, which I should, I will have 1, 2, 3. And it will get to 1, and then to 4. So it'll do like that. Now this function has two x values for the same y value. So that's why we have y equals x and not x equals y, because then we'd have to square root if we want to do something. And then that x square root can either be positive or negative, because remember that if we put in a number I mean, not in here, if we square a number, let's say 4 to the power of 2, that is equal to negative 4 to the power of 2. They're both 16, because negative 4 times negative 4 is also 16. Now, if we move on, oops, there we go. Now, that's a review of functions. Now, derivatives. What is a derivative? Well, if we have two functions here, if we have the same x squared, and here, so y equals fx squared, which is equal to f of x. F of x is a really simple notation. It just means the function of the function in respect to x. So it's x, so it could be in respect to z, it could be in respect to anything. So f of x is going to go up here. You can replace y with f of x, and here you're going to have an x. Now it can be g of x, it can be anything. The letters are all replaceable. You can have anything in respect of anything. Now, it's always easier to do f of x and y, because those are the most commonly used things, most commonly used variables, but you might want to get used to using others, since there's different notation. So a parabola looks like this. Now, it's curved, right? So this is x squared. Now, a derivative, f prime of x, looks like this. Now, why is that? Well, because the rate of change, this is a new word, is going up. So the derivative of, so let's have, so f of x equals x squared. Now, f prime of x equals 2x. It is not equal to x. So 2x. So why is it equal to 2x? Well, if we actually were to graph this, which is actually pretty hard right here because it's so small, this screen. If we were to graph this, we have 1, 2, 3. And let's say we graph this really small. 1, 2, 3, 4, 5, 6, 7, 8, 9 up there, right? That's 9 up there. That is 1, 2, 3, 4, and 1. So, and this is 1, 2, 3. This is not to scale. This x is more y than the y, so it will look kind of weird, but hopefully that's okay. So this is curved. Now, the rate of change is how fast is this going up by. So if you sub in into f of x, which equals x squared, if you sub in an x, you'll get the y value. Now, for a derivative, f prime of x, which equals 2x, if you sub in the x value, you'll get this rate of change. So the rate of change will be what determines how fast this increases, how fast the curve goes up by. So this is how I would interpret it. Let's say you have a function that looks like this. Okay? Now, if we have the derivative of that function, then it would look like this. Now, the rate of change for the parabola was a little bit harder to demonstrate, but here you actually can see the rate of change. So the rate of change here, which is just the tangent. A tangent is a line you put that is perpendicular to the curve. So this line is tangent, this line is tangent, this line is tangent. And you can have any line tangent to any line. Let's say a circle, let's say you have a circle, you can have a tangent there, 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 there. There's tangents everywhere, right? So this graph right here has 4 tangents at 0. That means that the slope of these tangents, we're going to call that m, equals 0. So what does that mean? That means that the rate of change right there is 0. So if we were to graph this, this is f of x. This is f prime of x. Okay? Now, that means that if the rate of change is 0, that means the f of x is also 0. Now, we can see that this is positive. This whole function is positive until here. There it's going to go down, but it doesn't matter. We're just looking up to here. I'm going to have another color here just to represent that. I'm going to get up to here and here. So what does this mean? Okay, so the rate of change says that this function is going up until it hits 0. It hits a ceiling. So that means if it's going up, that means it's positive. It's in the positive part of this f prime of x, of this derivative. Now here, between this 0 and this 0, it's going down. So that means it's going to be under 0. It's going to be negative. I'm going to put f of prime of x here. I'm going to say this is positive and this is negative. So we got this point here, and these 2 points. Now let's see what happens here. So we have a y-intercept. Now y-intercepts don't matter for derivatives because the derivative is totally different than an actual function. The derivative will only care about the rates of change of this function. It doesn't matter where the y value is. It doesn't matter where the roots are, which are when it crosses 0. Because the roots of f prime of x, are when the rates of change of f of x is 0. So as you can see, I have 4 points where the rate of change is 0, right here, 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 and here. And I have 4 places, 4 roots for this function, for this derivative function. A derivative is also a function. Now, you can see that here it's going up. So here we can have a really high y-intercept for this, though it doesn't have anything to do with this y-intercept over here. It's just a coincidence that they're the same. If this was going down like that, then the y-intercept would be at the negative side of the derivative. Now, here it hits 0, and here it's going down again, so we'll put it down. As you can see here, in this spot over here, it's more steep, the increase, than here. So that means the increase of the function here is more than over here. And now, I'll just get rid of that, and now we hit another 0, and then we start going up again. So this function would look like this. Like that, and like that. Hopefully I did that right. So it's going up, so it's in the positive. Then it goes down, it's in the negative. Then it goes up again, it's in the positive. And then it goes down and up. So that is the basics of derivatives, and I will be explaining the rules of how to actually get a derivative from a function in the next video. Thanks for watching.